Okay, hello everyone, and thank you for joining. My name's Michael Downey, and as host of today's session, I'm very pleased to welcome you to today's AWRI webinar. Today's session will provide an overview of best practice strategies for effective spray application, and this webinar precedes a number of practical spray application workshops to be run in 4 South Australian locations later next month. There'll be some more information about these workshops later in the webinar, but if you can't wait till then, jump onto the AWRI website where you'll find out all the details for these events. Now, I'm fortunate to have with me Alison MacGregor, who will be guiding the conversation for today's webinar. Following a Bachelor in Ag Science, Alison joined Department of Agriculture Victoria in 1988 in Viticulture R&D. She then held a position as Regional Chemical Standards Office with responsibilities for investigating spray drift, residues, and issues around chemical use and policy. In 1992, Alison took on a research project investigating pesticides in fresh and dried grapes and wine. This research underpinned the development of industry extended withholding periods to meet export MRLs, which is now referred to in industry as the dog book. Alison has been involved in a number of an extensive range of industry-funded research projects, including investigating doses for efficacy of fungicides in viticulture, development and facilitation of spray application training, relationships between spray equipment, spray volumes and disease control. In 2006, Alison moved to private consultancy, initially with Scholefield Robinson Horticultural Services, then with Sunrise Mapping, and more recently as an independent consultant. Now, it's fantastic to have Alison here, but I also invite you, the audience, to join today's conversation. To ask a question, please open the Q&A section of your webinar, type in your question and click to send. Feel free to send your questions in at any stage and we will address them at the end of the webinar. If you'd like to get involved through Twitter, please use the Twitter handle @the _AWRI. The webinar is being recorded and will be available to view later this afternoon from the AWRI's YouTube channel. I'd just like to also acknowledge and thank Wine Australia for providing funding and support for AWRI webinars. For those that are just joining us, welcome. The topic for today's webinar is effective spray application, and I'll hand over now to our guest speaker, Alison MacGregor, to start the conversation. So, Alison, if you want to click on the share button on your end and click to open your presentation, we can get started.
All right, is that visible?
Yes, that's all visible. Go
right,
ahead.
Yeah, thanks, Michael. And thanks for the introduction. Thank you also for referring to the workshops that are going to be held during October in South Australia, because any questions that you have arising out of this webinar, it'd be terrific to see a lot of people attending those workshops and we can flesh out some of the questions there. But what I promised to talk about in this webinar was the how, when and where of monitoring spray deposits and how to interpret patterns of deposition. I'm not going to have a lot of time to talk about setup today because it's only less than half an hour, but I'll refer to a couple of just basically a little bit about air and a little bit about liquid that would be critical things for everybody to be looking at early in the season. But starting with a story and what that I guess underpins why I think it's so important that you are all out there and your staff are all out there checking deposition. This is a vineyard that I visited in February at the request of a winery. The winery were anxious about taking the fruit from this vineyard because the powdery mildew infection in it was quite high, they felt, and they're worried about taint in the wine, and so they wanted to reject this fruit. I was asked to go out and give an independent assessment of the percent of infection in that crop, and I took Bob Emmett with me, and this is how the bunches looked, and it was, you know, powdery, tucked away in a lot of berries in these bunches. There were signs of infection from quite early in the season. We assessed the crop using the assessment key that's now available as part of the PMAP app, powdery mildew assessment app that you can put on your phone. And we assessed according to normal protocol. We looked at 200 panels. We looked at bunches in 200 panels. And just these little dots up here on the left-hand side, if you imagine, we walked down this row and we looked at a panel on this side and a panel on that side and assessed both of those and kept walking down, looked at a panel here and a panel there, and so on through the vineyard. Now, just for ease of showing you what the results look like, I've colour-coded the scores just for a map that you're about to see, an overlay. And so if you see yellow, that means there's not much damage. And if you see red, then there was a lot of powdery, and the colours are sort of graded in between. And so it might look like then, for example, that panel has no powdery and that one has about 8% and this one has none and that one has about 40%. And so on. Now this is what the whole vineyard then looked like. So these are our 200 panels. And so we walked down a row and we assessed both sides and so on, and came back in this one and assessed. And as we went through this vineyard, it became so apparent as you'd walk in the end of the row that there was a good side and a bad side. And in fact, not just a good side and a bad side, but on the bad side, it was a particular zone. The top cordon had particularly high infection. And we were never sure whether it was going to be the right side or the left side as we walked in, because it seemed to swap. But you can see it in this map here. So for example, looking down this row here, as we went down this row here, there tends to be a higher level of powdery on the eastern side than on the western side. And then coming back down here, seems to be higher on the eastern side than the western side. So we've got more red down this side than on this side. And that row there arguably is, a bit hard to say that one is higher than the other there. Coming in this one, probably the eastern side's a bit higher than the western side. So there was this pattern of part of the canopy being worse infected than other parts. And to me, that says it's not about timing of the sprays, but it says that there was a whole zone that got missed. And if I don't know where the tractor would have been, what pathway the tractor took, but I can imagine that if the tractor was coming down here and spraying out as it heads south, spraying out the right-hand side of it, spraying out on the western side, and that missed, and then it comes back in here, like does some trips up and down, and then it comes in a few rows later up on this side, and now we've got the right-hand side spraying here and missing this. And then presumably it's gone up and down and up and down, and it's come in this way, so that the right-hand side is missing here again. And at the end of the season, the crop was rejected. So it's a sort of sad story. But it just means that it's so important to be assessing your deposition right from early season. So in 2016-17, it was a horrible year for some people. Powdery mildew was controlled with varying success by different people. And that says to me that some people, obviously what they're doing was right, and some people were completely missing the boat with how they were trying to approach it. And I was contacted by another client at the end of the season and went and looked at their vineyard. They put on 24 sprays for powdery mildew, which is ridiculous. They're actually not a wine grower, but 24 sprays, partly because they're trying to protect it from powdery coming in from a neighbouring vineyard that had been neglected. But if you can measure what you're doing, you can manage what you're doing. And so that's what I want to focus on now. So how do you assess spray deposits? Well, where and when? I'm going to roll them together because they're very interrelated, I feel, the where and the when. Every growth stage, you're trying to spray a different target. So when do you assess your deposits? You've got to assess them right from early, from the very first sprays, even though there's not a lot there. And you think, going to all this trouble with water-sensitive papers or dye or whatever, when there's almost no canopy there, maybe we'll wait till there's a lot more canopy. By the time there's a lot more canopy, a lot of your early sprays have already either done a good job or not done a good job. So get out early with your assessments. And the target that you're trying to spray changes as well. So where you would assess is going to change. At bud burst, I would be looking at bud burst at seeing whether I could get really good wetting of a cordon, because a cordon can absorb a lot of water, but you might be really wanting to drench that for a bud mite spray. Early in the season, I would be looking at whether I'm getting sprays. Oh, let's go back up one. Yeah, so at bud burst, I would be looking at whether I'm drenching the cordon, not whether I'm creating a whole cloud of spray going everywhere else. And if I've got a minimal pruned canopy, I would be looking at whether I'm actually getting spread right across it. Between bud burst and flowering, we've got to get deposits on all green tissue, and it's really easy to get sprays onto this. And it's pretty easy to get sprays early onto this. But the little inflorescence is actually a very hard surface to spray. And I would really advise people to do what they can to assess the deposits that they're getting on inflorescences, early inflorescences, because they're really, it's quite hard to get a deposit on there. At flowering, where are you going to assess your deposits at flowering? Well, I would do it in the flowering bunches. Water sensitive papers are pretty bad at simulating a bunch. So this might be a time in the season when you go out with kaolin or a dye and spray something, although you might have to do that a little bit before flowering, but spray something that you can actually see deposits of on the bunch itself. Because this is a really, really hard surface to spray, and you need to get your deposits into, for example, this little part of break in the cap. This is where you need to get your botrytis spray. So don't worry about how much is all over the rest of this foliage. You really need to be assessing what's landed here, and that's very hard to do with something like water sensitive papers. So you might think of an alternative way there. Inside the canopy, deep inside the canopy after flowering, you're going to start to get secondary shoots growing, and you've now got a whole wall of canopy possibly blocking access by the sprayer to the inside, and yet you've got this very vulnerable tissue, and that's where you might start getting powdery mid-season starting in there. So that would be another target zone to be looking at. Pre-bunch closure, you're going to be spraying right up to pre-bunch closure, but the canopy starts to become quite a monster to spray. So getting right inside, assessing inside would be critical. Now I just want to talk a little bit about powdery mildew, because the timing of those powdery mildew sprays then becomes, to me, a cue about the timing of assessing my deposits. If you think, well, powdery mildew early in the season, whether it starts from an ascospore infection from a Cleistothecia that's then infected a leaf and then starts to spread, whether it's a flag shoot infection that then starts to spread. Either way, we've got these little infections. They're going to start growing filaments. There's going to be little conidia spores on the tops of these. These are all going to start shedding off every day, blowing in the breeze and spreading throughout your vineyard. Now, this is all happening very early in the season with a new generation or new colonies starting every 7 to 10 days. So it's a very rapid turnaround. That would be when I would be out checking deposits. So this, I don't know if Peter McGarry's logged in to watch this, but this is a chart of Peter's that is available on the AWRI site on various documents about powdery mildew. But I like it because it really drums home the idea that we've got to get early sprays on for powdery mildew. And so along the bottom axis here is days from bud burst. And so here's around flowering. And up this axis is the percent of powdery mildew that's likely to be present in the vineyard. And so early on, as those first colonies are just starting to spread, we don't see a lot of powdery, but then it starts to take off and we start to see it more. And then, but if we can get these early sprays on, we can push that curve out, and we can push it out into the season and delay the onset of this sudden hike in incidence of powdery, and therefore delay this severity of the powdery. So these are when our critical sprays are going on. So this is when we need to be checking deposits. So where do we check them? Well, there's always going to be huge variability in deposition in any one canopy. I'm going to come back to this picture in a minute, so I won't delay on it further here. But I would encourage you to be assessing the top of the canopy, the middle of the canopy, the bottom of the canopy, and there's a poll. This is how I do it. this works for me. This is electrical conduit, this pole. It's got clips on it that you can't really see them very well. There's a picture somewhere later showing a bit more clearly the paper clipped into the pole. But I would be assessing on a pole tucked into foliage. This one's a bit exposed. And high, medium and low, I would be assessing different angles, and I would be putting several poles out in the vineyard. Now, how do you assess your deposits? So what sense do you make of what you see? And I think this is a really important question, and I think we are a step closer to being able to make sense of this. And that's perhaps, if there's one take-home message from today, I want it to be that. There are, older traditional methods of measuring deposition. I've used tartrazine and fluorescein. Both of those are lengthy things you have in terms of the analysis of them in the laboratory. Metal ions, a lot of laboratories overseas use metal ions or have in the past. The Americans in extension articles talk about blue food dye and photographic paper. I've never tried it. It sounds expensive using photographic paper. Fluorescent pigment, fantastic. Can't use it later in the season, and very hard to quantify unless you send samples off for analysis of the UV, but hard to quantify, but excellent to demonstrate where the dye is. Water sensitive papers, cheap, simple. I've never thought particularly accurate, but you can keep them, so they're fantastic for keeping a visual record of what's happened. Kale and wettable powder people have been using. So nothing new there. However, in the pipeline, a couple of new detectors that are being investigated. Scott Post in New Zealand is looking at a dose measuring device that would be in the canopy and give you real-time feedback on dose. Also, Andrew Landers in the US is developing something similar. So maybe soon we'll have something that gives us real-time feedback to the tractor cab saying we did or didn't deliver the dose. But at the moment, we're still stuck with old-fashioned methods. I'm going to talk about water-sensitive papers. There's a closer-up picture of my electrical conduit with a clip and some papers on it. We've got to be able to measure what we see, though. Now, it is exciting because in 2015, with funding from the GRDC and the West Australian Department of Ag, a phone app for quantifying deposits on water-sensitive papers was developed. And this is a great little tool. It's called Snapcard. The picture on the right shows you what the screen looks like. You take a photo with your phone and of the water-sensitive paper, and then you ask it to calculate the coverage, and it will tell you. And on this example here, for example, it says their model predicted 10%, which is based on some input data you provide, which I don't use for horticulture. And it says your coverage was 14.7. And so that way we can start to get confident about what sort of coverage we're actually achieving. Now, how accurate is it for viticulture and the sort of paper wetness that we like to see in viticulture, given that it was developed for broadacre and very low volumes that they apply? So there was a lot of talk last year about whether it was really useful for us and how wet should they be for us and how accurate it was. We weren't the only people asking those questions, and Jason Ferguson, a PhD student from Queensland, has published a paper, and I've just given the title of the paper there, you don't have to read all that, published in the journal that I've shown there. Basically, he compared the coverage on water-sensitive papers and chromacoat cards, which are these alternative, if I can get my mouse working, this paper down here. He compared the deposits that Snapcard said, the coverage as quantified by Snapcard, against coverage quantified by a set of other software, image analysis software. And he did that by sending papers that he sprayed, the same set of papers out to a whole lot of labs that had those different image analysis. And so the co-authors on this are from research centres in Nebraska, Texas, Brazil and Queensland. And they use 6 nozzles. Now this is the interesting bit, because there's 6 types of nozzles represent the kind of spray deposits that we are delivering. So they included fine, medium, coarse nozzles. So they weren't just looking at very fine deposition. Now, here's the good news. all of the software varied a little bit. They all showed the same trends, and Snapcard was as good as any of the others. So yes, we have a cheap and easy and as reliable as anything we might pay for by sending expensive samples away. So that's fantastic. We can use Snapcard, and I think people should take some confidence and really start playing with it. Now, meanwhile, I didn't know that other trial was going on, but I did wonder about how reliable it was, and I used it a lot myself last season. What I did with it was compare Snapcard, which I found used a lot of my phone memory. Sometimes if I took a photo of the same card 3 or 4 times, I came up with quite different results. So if I doubted the result, I retested it. But the fact that it could give me quite different results worried me a little bit. I compared the assessments that I made using Snapcard against the assessments that I made for those very same papers using a visual key that was published a decade ago and I have used previously. And that's the on the right-hand side, those grey images. And so every one of the papers I compared using both to see how accurate my eye was and also how accurate Snapcard was. And here's the result. And I think it's really quite good. So up this axis is the rating as Snapcard determined it. And on this axis is the rating as I determined it using the visual key. Now, sometimes if I wasn't sure if it fell into one category or the other, I landed it in between. So I do have some halfway marks. So for example, between 18% and 35, I would have 27 in there, or 26. So how did it go? Well, if you look at this dot here, I rated it at 40 and Snapcard rated it at 40. So that's great. If you look at this card here, Snapcard rated it at 60. And I would have just, there's no way I would have called that a 60. So I've called that one a 27. And so there are instances where Snapcard was, I felt, way off beam. I've removed some data points, particularly from the wet end. At the wet end, sometimes if I'd rated it as being quite wet, Snapcard's rated it as having very poor coverage. So I think its interpretation of the image is not good at the very wet end. So ignore those. If you're looking at it yourself, don't expect it to know what to do if it's wet, like these bottom right ones on the Fox key. So Snapcard is very good. But you can also, if you get your eye in, just use a visual assessment. So how to interpret the patterns? What are we looking for? Well, there are some general rules with coverage. We have to have pretty good distribution of fungicides across the surface. We know that. Syngenta some years ago and have continued to publish these figures saying we need about 50 to 70 drops per square centimetre for fungicides. Jason DeVoe from Canada did some work in the last couple of years in vines and in tree crops and says that you need 85 drops per centimetre or at least 15% coverage. I mucked around using just some calculations to work out if we were trying to land 2.3 micrograms of sulphur, how much coverage would we need? And I've come up with 15% there as well, if we've got a 600 grams per 100 litres. So let's say 15% coverage is our target. We don't have much more to go on than that because do we know the required doses of agrochemicals? No, it's just not available. We still don't have a rapid and accurate test for quantifying dose. So we're just guessing, really. Do we confidently know what 50 to 70 droplets per square centimetre would look like? I suspect that probably you're not. I'm not confident at a glance. I have to keep refreshing against a key, but I can keep my eye in pretty well once I am constantly referencing back to a key. And I think that's the thing for me, is to feel that I know that I've got something to reference against, and I go, I'm at least looking for something that looks this wet. And that, to start building some confidence like that, at least allows you to look at your own deposits and say, that's not enough. In this part of the canopy, that's not enough. Otherwise, we're just guessing. So we do know a lethal dose for sulphur on young grapevine leaves has to be 2.3 micrograms per square centimetre of sulphur. So that's a really good starting point. We also know that for some of the fungicides, it's actually lower than that. We don't need the kind of coverage we need of some of the more sophisticated chemistry is less. But given that sulphur is a very critical part of most of our spray programs. I think that we should use that as our benchmark for how much coverage we've got. And as I said, I did the calculations, and I'm very happy for anyone to challenge my maths. But basically, if you get 15% coverage of a 200 micron droplets, then you'll have landed your 2.3 micrograms of sulfur. If you're putting on a dilute mix, you actually need, if you're putting on 200 grams per 100 litres of sulfur, for example, you need 45% coverage. And that's quite wet. I think this little paper that's on the right in this picture is about 35%. So I think it's helpful for people to start collecting examples of water-sensitive papers that, according to SnapCard, are at least 15%, and start getting your eye in about what you're looking for. So these are some examples that I've found published elsewhere by different people, so either Syngenta or from the Fox Key or Jason DeVoe from Canada, or some of my own water-sensitive papers. Yeah, so start developing up a collection yourself of papers that are at least 15% coverage. Now, how does this all apply out in the vineyard? We, as part of a Murray Valley Wine Growers project last season, driven by Julian Connellan and with Peter McGarry and Bob Emmett involved, I was peripheral to that project to do some calibrations and look at deposition. And so there were 6 vineyards in the project. Julian, from those 6 vineyards, collected, well, 226 actually water-sensitive papers, because each of them was folded in half. We ended up with 552 bits of data from those. In each vineyard, there were 6 or 8 poles like this. This is exposed, they were hidden. There were 3 heights per pole, so clips at the 3 heights, high, medium and low. And 4 surfaces per height. So there's a vertical back and front and a horizontal top and bottom. So from each pole, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 surfaces, representing quite a good spread through that canopy. Here's an example of what the papers would have looked like. So so if we just look at this pole here on this set of paper, this is the back and the front of the vertical high clip, and the bottom and the top of the vertical high one. And then these 4 are the middle clip, back and front of the vertical, and bottom and top of the horizontal. And then the bottom clips, back and front, bottom and top. And by always placing them in the same positions on every single piece of paper means your eye can really quickly start to find a pattern. And I want to draw your attention to this position here. Now, this is an exposed pole, so that doesn't really tell us what's happening in the hidden canopy. Unfortunately, this paper must have fell out. But we've got a bit of coverage here. Not a lot there. And we can keep going through, because they've all been saved on a record in the same sequence. We can compare them. And yeah, so here is the same position as here, is the same position as here. Now, if you see what I'm seeing, these are very yellow. There's not a lot of coverage on those. So I would say we can see from a set of papers that is recorded like this that that there's a definite spot in this canopy that's really hard to access. Just going to another machine, and I've just picked 2 of these machines sort of randomly from all of the ones in the trial. But so again, we can see a spot in this one. I would say here. We've consistently got a zone that we're not accessing. So over all of the 6 vineyards, I want to show you what the deposits look like overall. And this is the zone that really makes me very frightened. That out of 6 vineyards, the underside of water-sensitive papers high in the canopy only had 3% deposit on it on average when they were scored by SnapCard. Now, some of the papers they were a bit blue from humidity, and I didn't want to assess them using SnapCard. And I did assess them using the Fox Key, those extra ones. So the 552 cards were all assessed using the Fox key. And so now this data set on the right is a total of over 1,000 water-sensitive papers. And you can see that the coverage, again, on the underside in the top of the canopy was only 6% coverage. And in fact, all of those papers with the red squares around them they all failed to have coverage that would meet that 15% coverage for a sulfur spray. That's pretty alarming, because that's not just one vineyard, that's across all of those vineyards. And it was not that late in the season. It was late October, early November, so there's still quite a lot of canopy to grow. So what can you do to improve your deposition? I'm conscious that I'm just about out of time, so perhaps, Michael, shall I leave it at that and we ask some questions, or do you want me to add a couple more slides here?
Hi, Alison. I suggest keep going through to the end.
Okay.
We've still got a couple of minutes. I think we'll be all right.
All right. There are two main things that I want to draw to your attention with regard to adjustments. I can't describe adjustments that you should make on any particular machine from my desk here. You know, that's crazy. We should do that in the vineyard, and going along to a field session is obviously the most powerful way of sharing those ideas. But I do want to draw your attention to a couple of things that also came out of last season. I've always been very obsessed with air and less worried about nozzles, other than being I like fine droplets. But I calibrated these sprayers as part of the trial, the Murray Valley trial last season. And so in this chart here, you've got the 6 vineyards, 1, 2, 3, 4, 5, 6 across the top. And Vineyard 2 had 2 sprayers that I calibrated, and Vineyard 5 also had 2 sprayers. These 2 sprayers were the same type. These 2 sprayers were different. This one was, one of them was a boom, because this guy uses a boom early season, so he doesn't use air assistance early. In Vineyard 2, the 2 sprays were both recalibrated. Now this line here is the proportion of nozzles that had an output that varied by more than 10% from the average for that type of nozzle. So I wasn't comparing, on this sprayer, for example, I'm not comparing green nozzles with grey nozzles or red nozzles. I'm only comparing green nozzles with green nozzles, or yellow nozzles with yellow nozzles, for example. But so on this sprayer here, 31% of all of the nozzles were more than 10% different from the mean for that type of nozzle on that sprayer. In fact, often it wasn't even on the whole sprayer, it was just on the side or on the fan. So the variation within these nozzles was so broad, it was astonishing. At Vineyard 2, he ditched all of the nozzles, bought new nozzles, and we retested, and in fact it fixed. They became much, much more uniform. Now, why does that matter? Well, it matters because, yes, you're putting droplets out into an airstream, and the airstream might compensate for any variation in the nozzles and spread everything around and even it all out. Well, I don't actually think that's what happens. So just looking at the air blast, partly because it was easy to diagrammatically show you, only 4 nozzles per side early season on this one. But the 2 graphs on either side show the variation from the mean coming out of each of the nozzles on either side. And so we've got the mean runs straight down the middle, and then variation either less than the mean or greater than the mean out to either side. So this nozzle here was putting out something between 5 and 12% or so more than the average for that nozzle size on that machine. They were all the same nozzles on this machine. This down here, this is absolutely putting out the mean. Down here is putting out a bit less than the mean. Now, putting out less than the mean down the bottom is not a bad thing, because a lot of that was just going straight under the bottom cordon onto the ground anyway. But putting out a lot more than the mean up here, when this is shooting over the top of the canopy, compromises what else is going into your canopy. But this is the zone that worries me. On this side, this nozzle was putting out significantly less than the mean, which means that overall the volume going into the canopy just in this zone here is underdosed compared to whatever you expected or were hoping to achieve in this canopy. And this is the kind of thing that leaves you exposed. And by having done this calibration, that then is a really good driver to help you know where you should be assessing. Just looking at one of the other sprayers as part of this same trial. This is actually not the sprayer, it's just that the photo, I stole this photo from the web, but it's a really neat way of, it lines up really nicely with my graph. So it was the same type of sprayer, but not this particular one. Just in summary, what happens here, looking at each side, so 2 fans on the outer arm, and then 2 fans facing in, 2 fans here. These 2 outer ones, 7.4 litres per minute from that side, only 6.3 litres per minute from this side. Well, why? What was happening? Well, if we look up at the chart here, this line cutting through the middle is the mean for that type of nozzle on this sprayer. So a green nozzle or a grey nozzle, the mean. On this fan, everything other than the bottom grey nozzles, the others were all running just a little bit above the mean. On this fan, these are all running, they're all delivering much less than the mean. So these nozzles were all something going wrong here. Whereas these green nozzles on the bottom fan, for example, over here, are pumping out a lot. So it's very variable. It means that every single row in this vineyard is getting a different dose. Now, knowing that is the first step to ironing it out. And I think that that's probably a very useful function at this point in the season, is to just test every single nozzle separately and know what the delivery is across the breadth of your machine. Now, air. I just want to talk really quickly about air because this is something which I think we totally underestimate. Air at flowering is something we should think about very, very carefully. Why? Because when air approaches a flowering bunch, we hope that it's going to come along laden with spray, slow down, intermingle into that little bunch, and then come out the other side all dry, having left the chemical inside the bunch. What actually happens due to laminar flow is something more like this. So the air, as it approaches that bunch, perceives that bunch as being quite a solid object. And so the air will actually race around, a lot of the air will race around the outside. Now, in fact, what it does is, as it comes around here, it tumbles around and you get this little vortex effect on this side as well. But nonetheless, there's a dead spot, and there's also a very high proportion of what's approaching this bunch will skim around the outside and keep going. So what do we have to do with air? Slow it down. This, you might have seen this graph, but it doesn't hurt to pull it out continually and rediscuss it. Kieran Murphy did this work in a wind tunnel in Werribee back in the late 90s. And on this axis, we have the amount of chemical retained on a grape bunch relative to our starting point. So this 100%, whatever was at 0 air, this is the amount of chemical that was retained on a grape bunch. Along this axis is increasing airspeed. So the droplets passing that little bunch hanging in a wind tunnel is increasing as we go out this way. So what does this blue line mean? At capfall, so we've got flowering bunches hanging in a wind tunnel with no air. There was a certain amount of deposit that was retained on those little flowering parts or flowering bunch. As this, I've lost my mouse. As the airspeed increases, look what happens to the amount of chemical retained on that little bunch. So some of it is landing and blowing off, being sheared off again. Some of it is simply not landing, it's just racing around the outside. So this means we have to manage air, and I'm not saying turn your air off. I'm saying manage your air so that by the time it reaches those little exposed bunches at capfall, that it doesn't race around them and blow everything everywhere except on that little flowering bunch. So think very carefully about your air. Now, how do you know if you're getting it right? By going out there with a dye, putting it in the tank, having a look and seeing what is actually landing on the bunches at capfall or just before. Now, I don't know the implications of applying something just around flowering. So you may do that just before, but know that you're not sending the air right around the bunch. there's a lot of things you can do to your machine to tinker with it and slow your air down. After catfall, once we get to bunch closure, sure, the air is beneficial then. At Raison made no difference. You know, once the bunch was closed, you couldn't really pump any more deposit through it. But at catfall, very important to not overdo the air. So you don't want this. We don't want a vineyard that has a very, very conspicuous stripe that is a consequence of some unfortunate sort of malfunction in part of the delivery of the spray. And we do, as an industry, need to tidy this up. And I think we now have a tool. Get out there, use Snapcard, or use a visual scoring system, but start getting confident about looking at water sensitive papers in tricky to access bits of the canopy and saying, that is not enough. We can do better than that. And start getting your head around what 15% would look like. And a lot of people have contributed to the work that I've presented here, and thanks to all of them. And if there are any questions, maybe we take some questions now.
Okay, thank you, Alison. We do have a few questions already. For anyone that's not familiar, if you want to ask a question, just click the Q&A part of the webinar, which will open up a box, type your question and click to send it through, and we'll receive it. So we've got a question from Martin about 3-row sprayer. Martin, I'm not entirely clear as to the context of that question. Perhaps you can send a follow-up question if it wasn't already answered in the webinar. We've also got a question here from Chris, who's asked, would the early season sprays required to prevent powdery mildew you referred to in the graph also increase mealybug and scale?
So are you concerned that by putting on powdery sprays early in the season, that then it's going to create a secondary problem? Sulfur sprays are not, no. Some of the more complicated chemistry, yes, there can be relationships between the toxicity of those to predators, etc. But if it's a sulfur program, I would say no. There's no reason to suppose that. I would have to know the chemistry that you're worried about, Chris, before being able to say whether there was going to be any spin-off effect. Yeah, have you got particular chemistry that you're worried about? I'm not going to be able to answer it off the top of my head. What I'd have to do is do some checking against Ari Hoffman's, the toxicity indexes that he's got for different products against different predators.
Perhaps you can send a follow-up question, Chris, or contact the AWRI directly and I can put you in contact with Alison, perhaps.
But that's it. It is a really good consideration. Everything in your spray program is impacting on something else. So it is a good question. I'm just, yeah, we need to know what chemical you're worried about.
Okay, so we've got Chris who's asked, yeah, he has confirmed I was worried about sulfur.
No, don't worry about sulfur.
Okay. Thanks for that, Chris. Nick's also got a question here. Where can the paper clamps for the poles be purchased from?
Yeah. All right. Those clips I bought out of New Zealand. Croplands were selling them for quite a number of years. And I asked them, back in May this year, I asked Croplands why they had taken them off their product list. And they said people were not buying them. So I said, start selling them again and let's start flogging them because they are brilliant. If there is interest within the industry, I think between the AWRI and Croplands and the manufacturer who's based in New Zealand, I'm sure we can get them back in circulation. I feel very strongly that that would be, just right across the industry, that would be a very good move.
Okay, thank you for that, Nick. Martin's responded with regard to his first question about 3-rower spray, and he said, just in regard to the disease pattern in the Chardonnay vineyard, why don't 3-row spray carts show poorer deposition patterns on outside arms?
Well, why don't they? They may do if, and that may have been part of what we were seeing in that vineyard. I don't know what spray was used. I don't know if it was a contractor. So in that example vineyard where I showed the map, I'm not sure of why. It's a delicate area when someone's had their fruit rejected, and I was very excited to sort of go drilling down into the why and, you know, what had gone wrong and how we could help. But that is delicate territory to navigate, and so you have to step back and wait for the grower to lead that one, which he hasn't done. So I don't know what spray he used. However, yes, with the outside arm, there is a risk that you haven't got spray coming in from the other side. So you're delivering into a different kind of airspace on the outer arm than you are when you are spraying, enveloping both sides. Why don't we see issues? Maybe we do. I don't think anyone's really tracked that. Relating powdery to the path of the sprayer.
Okay, another question here from Nick. Do you think spray controllers have made growers complacent about coverage?
I think being busy probably has made, I think being busy and not having a really bad season has made us all complacent, because we think that things are working because we don't have a problem. And then in a season like last year, which was so testing for some, in some vineyards, then all of the kind of cracks in the system became apparent. And I don't think it's the spray controller. I think the spray controller is great because you know the total volume you're delivering, but it does mean that people don't calibrate each nozzle anymore. People are inclined, I think, just to trust their controller. So if maybe, Nick, maybe that's what you're referring to in terms of the complacency. Get out and test all your nozzles. Look, it's a pain. You get really wet. There's a really neat little calibration tool for measuring the flow that we can show you. You know, if anyone's interested, chase that up and I'll show you how to find that. But it doesn't have to be a tedious thing if you just get it all over and done with in one morning, and it will be very revealing, nozzle by nozzle.
Okay, so Peter's also got a question here. Says, fantastic presentation, Alison. Any benchmark fan speeds that could be recommended for different devices?
No, because the fan speed is going to depend on the distance of the fan from the canopy, the type of fan. I think maybe that's something that we should, maybe that's something that we could try and provide some specs on, depending on what type of fan you're running. The airspeed that fan will still be running at by the time you get 40 centimetres, 60 centimetres from the fan, from the blades. Because the real question is, how fast is the air when it hits the canopy, rather than what is the speed of the air leaving the fan. And that's going to, if you can imagine that you've got your fans, if you've got a multi-fan setup and you've got your fans angled slightly back or slightly forward, your travel speed is even going to influence the rate of slowdown of the air. So if you've got your fans angled ever slightly forward, as you drive, the more quickly you drive, the more back pressure of air you're driving into, your air will slow down more quickly. If you've got your fans angling slightly backwards, and if you drive quickly, you're not interfering with the air you've just produced. You're not going to slow it down so quickly. So even though all those subtleties will influence your airspeed. So it's not as though we can say, okay, we have to run the fan at this speed. What you've got to do is test the speed at the canopy as you drive past. And, you know, little anemometers, and means having someone who's willing to, you know, hide under the canopy as you drive past with an anemometer, I suppose. But just something even as simple as that, so that you go, oh, okay, that's pretty fast. Or does that answer Peter's question?
Yeah, I think so. If it doesn't, Peter, send through a follow-up question and I'll forward it through to Alison. The last question we've got here is from Ben. Do you have a preference of sprayer-based on delivery of air?
I'm not sure I understand the question. Do I have a preference of the... Oh, okay. Do I prefer one sprayer over the other?
I think that's what Ben's getting at.
With respect to air delivery. No, look, in all of the spraying that I have done and mucking around with other people's sprayers, what continues to amaze me is how a really crusty old sprayer can sometimes do a really good job, and a brand new sprayer can do a really terrible job. every sprayer has to be set up for every canopy. And I think the dangers are in thinking, I paid a lot for this sprayer. I probably paid a lot for this new sprayer, and therefore it should work. And then taking it into Shiraz that's on a different canopy structure than a Chardonnay or a Gordeau, and assuming that it's going to do the same delivery, when in fact it actually should be set independently for each of those different canopy, presuming that they're pruned differently, or different ages, different heights, and then taking the sprayer, an identically set up sprayer into each of those canopies. You can't hope that it's going to do the same job in every canopy. And it won't do the same job at every time in the season unless you muck around with it. Once the canes harden off a little bit, once you get a bit of lignification in the canes, then the behaviour of the foliage, the interaction of the air and the foliage changes a lot, for example. So as the canopy progresses, the machine needs to be adapted to that. Now, that sounds like a lot of effort. So pick key times in the season when those really critical sprays go on, and then say, well, if the other sprays after that weren't so great, well, it doesn't matter, because at least we're focused on that critical time in the season. So that's when, make sure your sprayer is working then, irrespective of what brand.
Okay, thanks for your question there, Ben, and thank you, Alison, also for answering so comprehensively all those questions. That is it for the session, so we'll start to wrap it up. As I mentioned at the start of the webinar, there are 4 spray application workshops being held in South Australia. The locations are Clare, Renmark, Loxton and Pathway, starting on the 10th of October. They're practical-based workshops with in-field demonstrations, as well as a more in-depth look at some of the issues that Alison discussed here. If you'd like to register to attend one of these workshops, please visit the events section of the AWRI website, and from there you'll be able to register and book to attend online. Alison, before we finish, did you have any final comments or anything that you'd like to finish with?
I hope I haven't sounded like that I've got shares in Snapcard or water sensitive papers. I probably have pushed those products a lot, but it's just that we have a tool that we can use now, and we can start to some extent quantify what we're doing. And I think that's a breakthrough, to feel confident that you can make the link between what you're seeing with deposits and the dose that you might have landed is going to be a first for on a lot of vineyards, I think. So go and do it. Go out and play with your sprayer.
Okay, great. Thanks for your final comments there, Alison, and thank you also for providing the content for what I hope's been a very informative session for everyone out there. I'd also like to thank you, the audience, for attending and participating in today's session. Attendees will receive a follow-up email with a link to this recording. The next AWRI webinar is on the 12th of October. If you'd like to register for this session, please visit the AWRI website. The topic is biosecurity. That's all we have for today. Thank you again for attending, and I look forward to seeing you again at the next AWRI webinar.